So I'm Dr. Anthea Seles. I am the Secretary General of the International Council on Archives. Just to give you a quick background, I'll be talking a bit about artificial intelligence in archives, but I'm going to try and focus my discussion on dissemination and the impact that these new technologies have on dissemination. But in order to discuss that, we kind of need to look at the whole process of where artificial intelligence can be applied in archival practice, and then what this means at the end if we try and use it or allow researchers to use it to process materials that we may hold within our own institutions. So some of the background to this is I worked for a time at the National Archives in the United Kingdom. I was responsible for digital records transfers, so overseeing digital records coming from government departments to national archives. One of the issues we ran up against early on in the project that I was working on was that our government departments in the UK needed to do appraisal and selection and sensitivity review, so identifying sensitive information in the records prior to their transfer to national archives. The issue we were running up against was that there was too much information for them to process. In some instances, and I'll probably talk a bit about it in the presentation, we were looking at anywhere from a terabyte to 1.5 petabytes of information. If we put that in a Word document context, that's anywhere from 1 million to 1.5 billion Word documents. And there's no way any individual person can look at this. So we needed to start looking at automated technologies in order to start processing this material and helping our government departments get it to us as part of their statutory mandate. And we also then started thinking much more widely about the applications of machine learning and artificial intelligence from the point of appraisal and selection and even records management all the way to the point of dissemination. So how to make our collections accessible and usable to researchers that are using machine learning technologies. Is this going to work? No. Okay. So I'm going to give you a bit of an overview about what is artificial intelligence. I think there are many different ways that people define AI and what it means and what it encompasses. It can seem very much like this magical unicorn that can do everything, and it cannot. And I'll talk a bit about that. I'm going to talk a little bit about how it can be deployed in archival practice. So what parts of practice, and when I say archival, I look at it from the point of records creation, so records management, information management, all the way to the point of dissemination. I don't make the distinction, the break between records management and then archives. I'd like to at least talk a bit about points to consider if you ever want to use machine learning technologies in your archives. These are not always really advanced. These can be things like e-discovery software. So that's the software that we tested, which is off-the-shelf commercial software that's used a lot in the United States to be able to look at large record holdings for legal cases. And so that's what we tested when we were at National Archives UK. So these are not hugely advanced technologies that you need to deploy. And how does the use of artificial intelligence improve and or impact dissemination? Because what happens, the decisions that happen and the things that happen at the beginning will impact how you make it available and how researchers can use it at the end, which is why I'm looking at the whole thing when we talk about dissemination. You can't break the different component parts you can't break it apart into different components. They're all interlinked. So artificial intelligence, machine learning, and neural networks. So artificial intelligence is an all-encompassing definition for any activity where a machine or system takes information, structured or unstructured, to predict an outcome. So when I say structured or unstructured, structured here is like an Excel document where you have tabs. Whereas unstructured is Word documents, PowerPoint presentations, emails is unstructured information. But it's what actually is artificial intelligence. There's no real agreement amongst the many different communities that use the term. It is an all-encompassing term. I'm sure if you talk to a computer scientist, they'll have a specific definition. You talk to someone who's working in data science or in statistics, and you get something somewhat different. But it is an overarching term. Machine learning is the process of training a system to learn how to make a decision using a pre-tagged data set. So what does that mean? So essentially, if I want to teach a system to tell me, I don't know, what to keep and what to throw away, I have to train it to do that. And there are many different things that I have to do. I have to essentially mark up documents, for example, a Word document, to say, this is what I mean by defense information that I want to keep. And so you have to tag it with all the relevant information, and then you feed it into the machine, teach the machine how to do the work. And then you can then start feeding other information in. This is a very simplified version. It's a little bit more intensive, but then you can feed other information in, and it will normally render an approximate accuracy level in terms of what you're looking for. And then neural networks it's just like our brains. They identify patterns and classify information, and neural networks can be trained to do something similar. So a type of neural network, a very deep neural network, is facial recognition software. So facial recognition software will recognize skin color. One neural network will recognize skin color. Another one will recognize positioning of different features on the face. Another one will recognize eye color, hair color. And so that then, when you layer it back all together, and then you put in enough data into it, creates the facial recognition software. So artificial intelligence can be defined in many ways. Like I said, there is no standard definition. There are really two major categories: supervised and unsupervised. So supervised is when a human, like in a machine learning environment, needs to mark a data set up and teach the machine what it is exactly that you're looking for. This is, as we say in French, c'est pas anodin. It's not anodyne work. This is a huge amount of work. Because different commercial suppliers will tell you different levels of markup that you have to have. So for example, one commercial supplier that we were working with said you have to have 30,000 tags in order to properly start training the machine, and that's 30,000 tags per theme that you're looking for. That is a huge amount of work and a huge data set that archivists or others need to then work on to train these machines. And unsupervised data is, all the data is loaded into the system without any upfront human intervention, and the system analyzes the data and provides results. I would say be careful with anyone that's trying to sell you unsupervised learning, because it's already been trained to do something. You're not just getting a machine learning algorithm that is suddenly going to spontaneously do like the human brain does and make these types of connections. It needs to be trained to make certain connections. And so when a lot of companies try and sell you what they call supervised or unsupervised rather algorithms, it's that it's been trained to do something. It's been trained to recognize something. And you have to think about whether that pattern is what it is that you want it to recognize, or if you have to do then extra work on top of that to be able to retrain it. So an example is, I can have a database or a machine learning algorithm that's dedicated to finding, I don't know, different types of cats. But if I feed a dog's picture in there, it'll still come out with a result. It can still do unsupervised training and come out with a result, but it may not be the result that you're looking for. So these are the sort of how it nests a little bit. It's artificial intelligence is the overarching term, machine learning is a subset to that, and then deep learning is a subset to machine learning. So how can it be deployed in archival practice? So I think some considerations before we look at how it can be deployed. So volume and complexity of digital information complicates all parts of the archival process. You know, I talked earlier about some of the challenges we encountered with our UK government departments, you know, trying to review 1.5 billion potential Word documents. No archivist, no human can do that. And so these machines become useful in those contexts. When you're deploying artificial intelligence, whether that's for appraisal and selection, sensitivity review, or dissemination. Dissemination, it's a bit different, but at least in the processes that we control are, what are the questions we are trying to answer? And that's what I always start off with whenever I give these types of these presentations, is what's the question we are trying to answer, so that we can evaluate the results and see whether the results are helpful or meaningful or accurate. So in machine learning technology, accuracy is measured by precision and recall, which means how precise is the result that's coming out based on how you've trained the machine. It'll never be 100%. And that's another thing that will need to be managed as well, and something we're going to have to teach potentially researchers to manage as we look at dissemination, because you'll get researchers who will have different levels of comfort using these types of technologies. Some of them will be really advanced and they will understand that it'll never be 100%. You'll never get every single hit that you want. and other researchers will be less trained in this, and so we will need potentially to talk them a bit through that process, because there is a danger if they don't know how to use these technologies very well, they could make potentially high-level superficial decisions around the data that they're seeing and the outputs that these machines are bringing out that may impact historical research, that may skew even history. And it's something that we need to think about as we potentially deploy these technologies in appraisal and selection, because we could also potentially skew history if we aren't careful. Archivists do not have the capability really to do the types of evaluations that we may have done with paper records, and so these types of tools are useful. And researchers also won't have the means to review all digital information that archives hold. Our digital holdings are not going to get smaller, right? They're going to get bigger. And so researchers are going to have to learn how to use these technologies in an intelligent way to be able to access our holdings and process our holdings. And that's a whole nother question about levels of access we may wish to give to our holdings. Legacy and current information management practices impact the deployment of artificial intelligence from the beginning of the archival information management process to the end. So what do I mean by this? So when I was working in UK government and we were trying to ascertain whether a department needed to transfer information, often they had huge legacy holdings, I'm sure many of your organizations have them, where they didn't quite know what was in these digital holdings. They had them, they were holding them, they weren't really managing them, but there was potentially information in there that they needed to transfer. So one of the advantages we had by testing out some of these technologies was we could do a quick process over their records holdings, to digital legacy records holdings, to kind of see, well, what was in there. And some of these technologies produce graphs, so you can map on a graph the different dates and formats of the materials that you may be dealing with. And they said that they had material from about 1995, and we weren't seeing anything in the graph that showed 1995. You need to be careful with these technologies, though, because they measure the volume of information and in terms of the size of the file format. And you have to remember that in early digital days, our file formats were really small. So you got to take these visualizations with a bit of salt. So when you're looking at them, you need to kind of drill down and look at, in 1995, is there actually nothing there from 1995? We couldn't find anything. So we went back and said, well, you're saying there's stuff. You're saying that you had a shared records holding, but we don't see anything in 1995. Oh, well, we migrated our systems in 2000, and so potentially that might be the issue. So what ended up happening was they put an information management system in 2000, and it inherited the date of the migration. So all the records from 1995 were actually records that were dated to 2000. So they were already, 5 years off of where we needed them to be. So we actually had to find different ways to get in to these types of record holdings to find the material. But what does this mean for archives and dissemination? Well, it means that when I'm presenting the record on the catalog, I'm presenting the record of 2000, but calling it 1995. And it's how do we then explain when we're presenting these records into researchers that may be using these technologies or researchers that are just trying to find material from that period. It's that how easy is it going to be for them to find it? Now, there are multiple dates on digital records. I'm sure you've seen this. There's sometimes dates in the file title. There's dates in the record itself. There's the actual digital date that's attached to the record in the metadata, and they can vary wildly. So this is all stuff when we're looking at even just sharing information with our researchers, not even looking at artificial intelligence or these advanced technologies. It's how do we explain this to our researchers so that, or in our catalogs, to help them then reuse that information. But then it makes it difficult if they want to apply machine learning technologies, because then they're going to use these technologies, they're just going to look at the date and they're not going to think about potentially contextual information we might provide about the history of record keeping within an organization. So how can artificial intelligence be deployed? So it can be deployed in records management and information management. So you can use it to automatically classify records. You can actually use it to funnel the information to the right point in the classification scheme. One of the issues we had in UK government was that people weren't using the records management classification scheme because they found it too difficult. And so they were misfiling things, or then if they had a shared drive, they were filing it in the shared drive instead of putting it in the information management system. So artificial intelligence sitting in the background could actually make it easier for users to put things in the right spot and hopefully then make our job a little easier. There's also categorization, so it can take sort of forms Again, forms change over time, but it can take forms and then funnel those forms into the right folders again. And then, of course, there's retention and disposal. So it can help us ensure that we're properly maintaining and disposing of information. We need to be careful, however, because some of the decisions, we need to make sure that it's making the right decisions around retention and disposal. Of course, as I talked about, there's appraisal and selection. So that is what to keep and what to throw away, particularly when you're dealing with large volumes of information. There's sensitivity review. And so that was one of the main reasons we started looking at these technologies, was around sensitivity review. And there's a real distinction to be made when you're deploying these technologies around personal information, which is actually much easier for these types of systems to identify because they're regular expressions. So your social security number will be number, 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 maybe letter, number, number. So the system can then identify it much more easily versus what I call context-based sensitivities, national security, international relations. How much time do I have left? All right, brilliant. National security, international relations, information provided in context or in confidence, sorry, because these types of sensitivities are much more difficult for the machine to identify because they're context specific. In one instance, maybe not sensitive, another instance, very sensitive. And this is where we started seeing what is the strength of the human in this process and what is the strength of the machine. For digital preservation, it can help you identify at-risk file formats or materials. So you can train the machine to start saying, I don't know, 1995 WinWord documents are at-risk files. And you also have, the Digital Preservation Coalition creates its bit list every year, and that's easy enough to train a machine to look for. You just feed the file formats in, say these are high risk and these are the ones I need you to flag for me and look up so that I know that I either have to migrate them or I have to move them or find some way to preserve them. And of course there's access and dissemination, which I will get into. So artificial intelligence is already being used in government, different parts of government. So in the UK government, they were looking to help catch gangs behind mass scale benefits fraud. I think we need to be careful. Sometimes government, as I said, uses these technologies as a bit of a unicorn. They see it as an answer to all of their problems. It isn't. And particularly when I look at handwriting technologies, there's been huge advances, I'd say, within the last 5 years. So when I first did this presentation, and this is one from 2017, but I would still say these are still emerging technologies. They're not going to be able to identify accurately to a level of precision and recall. And then this puts at risk people's rights and potentially targeting the wrong people. Of course, this is a very well-known issue with artificial intelligence that was discussed in many books, and that was predicting recidivism rates in the United States and Texas. And because it would disproportionately disfavored African Americans, and there's a whole host of issues in this. And the machine was trained with biased data, and so then it spit out biased results that was towards the African American community. If you want to learn more, there's a lot of articles. This is the one from The Atlantic about the issues behind this. Also, Kathy O'Neill's book, Weapons of Math Destruction, about the application of algorithms and how they can actually create greater cause injustice, sometimes without meaning to, because they fail to take into account some really complex variables when they're trained and created. So points to consider. It is a tool. The machine has strengths and weaknesses. The human has strengths and weaknesses. Archivists, information managers, and researchers will not be made redundant. I get this question a lot. If I start applying artificial intelligent tools within my archival process or within my reading room, I'm going to be made redundant. No. We had this conversation when we were deploying personal computers in the workplace back in the early 80s, and none of us are redundant. So I think that we need to, manage it. It's not to say that these technologies won't evolve and become more complex, and there may be roles that will change over time, but it won't make us obsolete. The human is still absolutely necessary in this process. And like I said, it can't think for itself. These technologies still need a lot of retraining and assessing by a human in order to make sure the results are accurate. So like I said earlier, you could have a huge algorithm all about cats. You feed a dog in, it's still going to give you a result. But is it the result you're looking for? So some of the things we found, was around what machines do well. So basic things like Boolean searches, keyword searches, regular expressions, and processing at scale. So yes, it can process huge volumes of data that a human cannot. Where the human does well is the human understands context. It can infer context. It can make complex decisions that a machine cannot. And I would still argue that handwriting analysis is not advanced enough in order to allow a machine to arrive at an accuracy level that I would feel comfortable with as an archivist or as someone working in government. So I'm going to skip over this so we can get into the impact on dissemination. So what artificial intelligence can do, and these are some of the advantages from a dissemination point of view. It can interconnect previously siloed font or collections. So our actual descriptive practices right now are very siloed. We treat the material based on the provenance of the records, depending on where they're coming from, but we don't often sometimes make the link even through the authority controls between different fonts. And so what these technologies can do is actually help us start making those connections and enabling researchers to make those connections. Records in context, so that's the new ICA Descriptive Standard, allows archival collections to be more interconnected through entities and ontologies. So there's currently an updated version of records in context on the ICA website. Definitely go have a look. If any of you want to comment on it, they have a comment period as we speak. So the objective of the standard is to reconcile about four different standards that ICA has. So the descriptive standard, the authority control standard, the function standard, and the standard around descriptions in institutions and archival holdings. So we're trying to bring it under one umbrella and interconnect it all. If we use records in context, then what this can do is that it can allow artificially intelligent systems to process our collections to make connections between different entities. And this is not only within our institutions, but between institutions. So we know that sometimes for various reasons, archives may have a component. I think of people who work at the international level. They may have worked for their government. They may have worked for a UN agency. They may have worked for a charity. And it's how do we interconnect all of those internationally as well as nationally to help people understand what that person's contribution is or how an organization may have operated over different territorial boundaries or international boundaries. And like I said, it breaks down our silos in descriptive practices, and I think it can yield to new and interesting findings about organizations and people. But buyer beware. There is a question about how much access we may wish to allow researchers to our public records and data. So there's already researchers, particularly in the digital humanities, that are using these technologies. I think it can reveal, although it can make these interconnections, could it potentially make known sensitive information that, because all the different collections were siloed, could become sensitive or problematic. It's a question. And also, once data is mined and put in a system outside of the archives, what else can be combined to? And I think these are questions that we need to reflect on, and questions around how much access do we want to give? Do we allow any researcher to plug in any system, any sort of artificially intelligent system or machine learning algorithm into our catalogs? How are we going to manage this? And look at some of the questions around this. I think one of the things we also need to consider is that we are not the only ones that know how important our collections are. Large corporations like Google and others are beginning to become more aware of the vast volumes of information that are held in archives. The repurposing and the reuse of archival records and data has enormous value, and I think sometimes we've sacrificed a lot in allowing companies to digitize our archival records and data in order to get a free copy. And we need to be a bit savvier, particularly in the age of artificial intelligence, and what this can do, and potentially how this can impact citizen lives. So as I said, companies are beginning to realize the importance of the data that we hold. One example I might give are death records. They seem innocuous. Yes, under the privacy laws, they can be released after 20 years, but death records often contain reason for death. You put that in the hands of a health insurance company, and they start making connections between who your parents are, your grandparents are, your great-grandparents are. They can start seeing potentially medical histories that can then deny you access to health insurance or other things. And these are held in archives and publicly available. So these are the types of things that with the best will in the world, we want to make information available, we want to make it accessible, we want to make it usable, but what is the impact, though, on citizen lives now that we have these technologies and have these abilities to have, crawlers go through our systems? What does that mean for us? I think when we work with companies, in particular companies that are selling us free digitization or free this or free that, is why is it digitization free? Will the data be used to train an algorithm? When I was working in UK government, I disrupted a contract because I said, you can have access to these materials, you can help us digitize them, but you cannot reuse that data then to retrain your algorithm. And the contract ended at that point. So we need to be aware that this is in play now. What's the company's ethical stance? It's a guide. They can always change their ethical stance, but it's something to ask. What happens to the data once the digitization is done? And will there be an impact on people's lives? So coming to a conclusion. So how will you make your collections more discoverable via machine learning algorithms? So like I said, levels of access is something to reflect on. So it's something that's being discussed right now at National Archives UK about what we make scrutable, or what they are going to make scrutable to Google crawlers or any type of search engine crawlers, what they may hold back and may only be accessible if you actually go onto their catalog, what may be accessible to machine learning algorithms. They're looking at, are we going to make a machine learning algorithm available? Are we going to allow somebody to plug it in? What is this going to look like for us? What are the access controls that we're going to put in place? Are there archival records that we may not, even though digital, may not even release, that you have to come on site and look at? And which kind of is antithetical a little bit to the whole notion of digital, because digital is all about information dissemination and sharing. But I think as we get deeper and deeper and have bigger collections and more complex collections, these are definitely questions we need to start thinking about and asking ourselves. When working with commercial enterprises, particularly those that are looking to access huge data sets, the main question for me now is, what are you going to do with it? And no, you can't use it for any machine learning training. Implementing records in context, if we want to make our collections more discoverable and interconnected, is one way to do that. And they're actually developing a converter that converts your descriptions into RIC compliant descriptions. It's called RICO. And it's available, I think it's available, if not through the ICA website, then through the French Archives website. So if you want to test it out, you're welcome to do so, and I'm sure they would welcome feedback on that. And will you allow any machine learning algorithms to access your descriptions? So again, coming back to levels of access and how much we're willing to share and under what conditions. So I have some further reading. I'll make this presentation accessible. There's a lot of stuff there. I think if I had to recommend one sort of thing that I read that was really impactful was Cathy O'Neill's book, Weapons of Math Destruction. And there's some French material in here as well. And Pedro Domingos, The Master Algorithm, is another interesting book definitely to read. I always recommend, there's some material in here that I don't necessarily agree with what they're saying, but I think it's good to have balance and get an overall view. Big data is one of them, where I think that there's a real sort of unicorn in the room, and big data is going to solve all of our problems, as will machine learning algorithms. It won't. I think you always have to come at it with a critical eye, but I think it's important, at least when I recommend readings, that people have a broad overview of the discussions happening across the spectrum. And that's it. Thank you.